Thanks, Randy. Well,
Yeah.
first of all, thanks for having me. Super excited to join. Excited. Wow, we got almost 100 plus people
Yeah.
here already. I'm sure there's some stragglers that'll show up a few minutes late too. So, really excited to be here. Like I was just telling you a minute before, I came from a background in mathematics and computer science, and then I worked as a software engineer a bit. And then I made the transition into data science, and I really had the same struggle that everyone else had, right? Like it wasn't easy for me either because back then, I applied for data science roles because I thought this job was going to be so awesome. I heard all these cool things. It sounded amazing. But then I realized that I couldn't get anyone's attention. Like no one even wanted to interview me. And, I got a couple of recruiters to actually talk to me, like third-party recruiters. And they're like, Kyle, no one's going to give you an interview because you don't have experience as a data scientist. All these companies just want people that have worked as a data scientist before. So I had that same struggle as everyone else, figuring out how to actually break into the field. Got my first role as a data scientist, worked my way up, changed companies a few times, kept working my way up. And then my last role as a senior director at a big marketing agency, working with Fortune 500 clients. And I started sharing a lot about what I learned through the process of both interviewing and getting jobs, but also hiring, 25 plus data scientists. So through that time, I was able to learn a lot. I started sharing with people, and a lot of people started following me, and I was getting 50, 60 plus messages per day on LinkedIn. So I couldn't help everyone. Everyone's like, hey, how do I become a data scientist? Can you help me? Can you do this? Can you do that? Can you give me advice? And it was really overwhelming. So what I did is basically just took all my information, created a course out of it, put it into a system, recorded it all, and was able to help, start helping people that way. So recently we had a lot of people sign up, and I made the decision to focus on helping aspiring data scientists be successful full-time, as opposed to trying to do two things simultaneously with my life. So now we're here hanging out on the webinar, hanging out with Randy, hanging out with 110 plus people here.
Mm-hmm.
Yeah, awesome. So yeah, I'm just really excited to help you guys answer any questions that you've got, help make you guys more successful. So let's do it.
Yeah. All right. So we're actually going to get started. And the way this works is this show is literally all you guys. So you guys make the show. So we have a Q&A box on the bottom. Leave any questions you would like. And we're going to be here for an hour answering any question that you guys have. So use this time right now to either think or just jot down some questions. And Kyle, if you want, I'll just read you some questions.
Sure.
All right. So the first one we got is from Diana. She said, what programming languages do you highly recommend knowing, forgetting in the industry?
Yeah, I mean, my answer to this is always Python. Just start with Python. Just get good at Python. If you can just get good at that, it's going to open the most doors for you, right? Like there's some companies that are just going to be straight up R shops, and they're not going to take you if you only know Python. But the majority of places are shifting towards Python because, it's a much better overall programming language because it allows you to deploy your models and productionalize them much more quickly, whereas R is a bit more limited in that regard. Also, there's a lot of buzz about the big data technologies, Hadoop and Spark and all these different things that everyone thinks that they need it now, or they think they're going to need it really soon, but most of them don't. Like it's still just hype at a lot of companies. So just start by getting good at Python, and that's going to be the best bang for your buck when you're starting out.
And I would like to add to that as well. So definitely agree with Kyle. And also to Python, the good thing is Python's very, compared to the other programming language like Java, C, and R, Python's considered one of like the most easiest interpretable languages because it mimics the English language pretty well. And also too, another tip is some things that I see that's kind of not bad, but they miss the point when getting to data science is sometimes when you're taking a course or maybe like data camp and you actually learn Python as a data science language, some people make the mistake of learning it just for data science, but they don't take the time to learn Python as a language itself, which is pretty crucial because it allows you to understand how the whole language works, how everything operates. And whenever you come to a situation where you have like trouble debugging, that's where like the time you take to learn Python as a language comes into play.
Yeah, and that's a really great point, Randy, because one thing that's happening in the market is it's shifting away from doing analytics and writing scripts and throwing them away, and towards automating systems that do the data science, that do the analyses for you, right? So in that regard, learning the software engineering, really understanding the language well, like you said, is just super critical, that moving forward, because that allows you to deploy models more quickly. It allows you to be more agile, and gives you a competitive advantage in the marketplace. So that's definitely huge.
Yeah. All right. So our next question is going to be from Inayat. He said, can you explain to me the basics of what data scientist is and what do they do? So very general question.
Sure. Well, fundamentally, it's about solving a business problem using data, mathematical techniques, and a computer. Like that's really it, right? So some problems will be easy. You'll use simpler techniques, right? If a linear regression solves the problem effectively, that's what you should use. Now, if you need a more advanced technique to get better predictions because there's a lot of non-linear relationships, then yeah, obviously you're going to use machine learning and different techniques and stuff. Or if you have unstructured data, then you might need deep learning, right? But fundamentally, you're trying to solve a business problem using data, using some mathematical or statistical techniques, and using computing to do it. So that's really what it is fundamentally. And what a lot of people forget sometimes is your goal is to solve a business problem. It's not like a research role. Like if you're working in academia and you're a researcher, or you're working for Intel and you're a research scientist, like that's different. Okay, data scientists, most of the roles are really applied in businesses where you're trying to solve a real problem. So don't forget about that. When you're thinking about data science roles, it's about solving problems and helping companies be successful.
Yeah, I totally agree. Yeah, we're getting a lot of questions, so I'm just going to be shooting you questions back and forth. So from Sammy, he or she said, how can I do a real life project in data science as a freelancer and to be ready for applying for jobs or interviews? Yeah,
so this is a great question, because if you want to get a job, like you've got to be able to demonstrate that you can do the job of a data scientist, right? Because if you think about the interviewing process, that's really what people hire for. If you can convince people at a company that you can effectively do the job of a data scientist, they'll hire you, assuming that they also want to work with you, right? That's another big part of it. But you've got to be able to demonstrate you can do the job of a data scientist, and simply having a degree or having the right background isn't enough. So absolutely, you've got to build those portfolio projects. You've got to build a couple projects that are important. So what you need to do is basically just grab any data set you can find and just figure out, okay, what problem would a business actually care about? Like if they had this data set, what problem would they be trying to solve? And set that up exactly as if you were working for a company, you wanted to put this in production, build the entire pipeline from start to finish, cleaning the data, doing the modeling, validating it, testing the whole thing. You can even deploy it, on some fake system, or Dockerize it, put it in containers or something. But basically take it seriously, pretend you were actually working for a company, and do a project from start to finish. Don't just do these little projects that you do in school where they demonstrate your ability to do like one really small thing, right? Because data science is a role that involves integrating a lot of different parts of the business and a lot of different skills. So you really just need one or two really good projects in your portfolio to be successful in the interview process. So take them really seriously and try to tackle it absolutely from start to finish, and don't just do like the easy thing. Even if the data is already clean, still do like super thorough EDA and automate it and write functions and show companies that you could do the job on a dirty data set, even if you've just grabbed a clean data set off of Kaggle or something. All right. So it's really about making sure that you're demonstrating that you'd be able to do the job in the real world.
Yep. And another thing I would like to add to what Kyle said, but it's more about the job you're applying for specifically. So a lot of people don't do this, but I think it's pretty important. You have to do your homework and understand like why you're applying to the company and what you can contribute to them. So do some research on like maybe projects or some things that they might have problems with. And that allows the employer to know, oh, wow, they did some homework. They know what problems we've been through. You have a higher chance of getting like remembered.
Yeah, Randy, like that's an awesome point, because one thing I tell people is you've got to have like one superpower, and you don't have to be the best in the world, but you've got to have some area where you specialize and you're above average and you're better than most people. And then you need to figure out how you can apply it at that specific company, at that specific industry, that you show that your unique background can solve their problems for them and help them drive revenue. Because if you can leverage your unique skills and show them, hey, I know that you have this specific problem with, churn or whatever it is, or targeting customers, and I've got the solution for your problem, like, they will hire you. It's so much better to stand out at being really good at one thing than trying to say, oh, I can do everything well. Like, well, what do you do well? Like, I can clean data and this, and this. Like, focus on the one thing you can do well that will solve their problem for them and make them money, and pitch that to them.
Yeah. All right, we got another question, and this is kind of like I think you made a post about this, but I think it's worth mentioning. So it's from Sam Vaught. How real are the job descriptions? Most companies ask for 3 to 5 years of experience in data science, even for entry level. Also, they have unrealistic requirements. How do you counter that?
Yeah, so they're not real at all. Like, it's all made up. So let me explain. There's a bunch of different reasons why, but one thing you can think about is you can think of the job description as a hard protective shell. It's a hard protective shell. It's a tactic that they're going to use to discourage people from applying. Now, right off the bat, you're going to be like, why would they want to discourage people? That's absurd. But you think about it, if you're the HR person and you post entry-level data scientist, you're going to get like 500 applicants in like 2 hours. And then you think, what the hell do I do with this? Right? So what they do is they write a job description that's totally unreasonable, and they know that they're not going to get this person. They know that they're not going to hire someone with a PhD with 5 years experience into an entry-level data analyst role. They know that's not going to happen, but they're just putting this shield up so they end up with less applicants, and hopefully they can try to hire someone that's a bit overqualified. But the reality is they know it's not realistic. There's more reasons too with job grading. The data scientist roles tend to pay a lot. So they tend to HR just inflates the job description to justify the pay and the salary band and stuff. But the reality is you can basically just ignore those job descriptions. What you've got to do is you've got to reach out to like a specific person within the company that has some sort of influence to push your application forward. So you still got to like apply. You can't just not apply for jobs. You want to apply for jobs, and then you want to start messaging people that you think are key decision makers within the company. So you apply for that, marketing data scientist role, and then you go on LinkedIn and you start searching for the company name, marketing, data science, or analytics, and you find every single related person. You bring up their profiles. You look at that list of people that other people clicked on, right? The related people on LinkedIn. You bring them up. You try to find all the data scientists, all the managers, all the VPs, and you pick 3 to 5 of them. You reach out to them directly, and you basically just briefly pitch yourself. Don't write them a long novel. Like, they don't want to read your life story. They want something short and sweet. But you've got to reach out to people, let them know, hey, 1, I applied. 2, I've got some unique skill that I think will help make your company successful. And 3, I'm really excited about potentially working for you guys. Because the reality is, I would get hundreds and hundreds and hundreds of applications when I was a hiring manager, but almost no one ever reached out to me directly and said, hey, Kyle, I applied. I'm super excited. I love your company. I think the work you're doing is cool, and I'm good at this one thing. Please give me a shot. If you do that, like, you're now in a very, very small group of people, and you're much less likely to be rejected. So just ignore the job description, put in your application, find people in the company that you think can influence the hiring process, message them directly, and just pitch yourself. Like, you don't have to spend months and months networking to try to get to know someone. Like, they want to hire someone that's good. Just reach out to them, be like, hey, I've got these skills and I'm super excited about your company. Think what you guys are doing is really cool. And that will take you a really long way.
Yeah. And also too, you got to keep in mind like perspective. So whenever you're cold messaging or messaging anybody or just networking in general, you have to put yourself in their shoe. Like, as a manager, what Like, you have to experience what they might be experiencing. You have to differentiate yourself in some way to make you stand out. So you have to really tailor your message or your resume to that company and make them realize or showcase like what you can contribute that makes you like worth being hired for.
Yeah,
That's what I would say.
Yeah, totally agree. And I think another quick point that's good, Randy, is basically the shorter the message, the better.
Yeah.
Like one time I made a post on LinkedIn. I think I was hiring interns like a year ago or something. And I was like looking for badass data scientists or something.
Yes.
And someone responded and they literally wrote one sentence. They said, "Kyle, I am the badass data scientist that you seek." And that was it. That was like the whole message.
I was sold. Okay.
I was like, oh man, I got to know this guy.
Love that. All right. Next one. So I think this is pretty important. I forgot the name, but the question is, can you explain something about the data science job interview? What kind of questions do they ask, and how can I be successful in one?
Ooh, this is tough because it really varies a lot from company to company. This is where doing your research really helps you a lot. You'll find that a lot of tech companies will focus more on engineering, right? Especially if it's a software company, there'll be a lot more engineering focused questions. Same with hedge funds and stuff where they've changed quant roles to data science. And other companies like a marketing agency, they're just not going to ask as many technical questions. It's going to be more about understanding the business problem. So you've always got to have the fundamentals down. Like you've got to be able to answer the basic stats questions. What's the p-value, this, and this, and answer the basic machine learning questions, and how do you detect overfitting and deal with it, and all these different things. So like you've got to know the basics, but you've got to kind of be ready for anything. But do your research on the company and try to figure out how they interview before you get there. And one good way to do that is when you get to the HR phone screen, don't let them ask you all the questions on the HR phone screen. All you have to do is seem like a normal person that they like and they want to be around, and you can get through the HR phone screen. Mm-hmm. It's your opportunity to start asking them questions. Be like, hey, what does the hiring manager look for? What types of problems do they solve? What types of people do they like to hire? What are the things that they asked you to look for? You know, when you saw my profile, what made you think that I would be a good candidate for this role? And they're going to tell you, well, we saw that you know Python and natural language processing, and the hiring manager asked us to look for that. Because then you know, okay, I'm going to study this stuff more and go in there and be prepared for this interview. So do as much research as you can if you want to be able to tailor your approach to a specific company, because there's just such a wide variety of roles. There's no one simple answer to say, hey, study X and Y, and you're going to be ready for the test on Friday. You know, it just doesn't really work that way.
And another tip, it's like a little hack that I think is pretty useful. So right before an interview, maybe with the hiring manager or with a company that you really like, a really good tip would be to actually go to Glassdoor and then look at the company. Because a lot of people that's been interviewed by them, they leave questions or similar questions that you can probably expect for the role that you're applying for, which could help you out a lot. All right, so another question that I see is from Ina Yacht. Again, it's pretty good. How is business analyst different than data science?
Well, so the business analyst role, well, it depends if you mean business analyst or data analyst, because there's usually a couple different roles in companies, but I think that you mean data analyst specifically, probably. Okay, yeah. But it tends to focus on simpler questions that you're going to do an analysis and you're going to more or less manually search for an insight. Yes, you're still going to use statistical methods. Yes, you're still going to use a computer, but you might be writing scripts in R or just doing SQL queries or using SAS or even Excel, where you're just looking for insights that you can pull out of the data. And it's typically more backwards looking, right? In the data scientist role, you're usually thinking about forward-looking predictions that you want to build a machine learning model that's going to optimize when a new customer comes in. So it's a little bit different role, but it's a good first role because you get familiar with some of the techniques and some of the technologies, but it tends to shift more towards databases and more towards inference and looking for insights as opposed to optimization and prediction and a focus on machine learning and automation, which is the data science role.
We have another question from Mauricio. He said, it's very difficult for an aspiring data scientist to get noticed, especially if you're a foreigner. So my question is, how do I get ahead in the process of recruiting? And how can I make my resume stand out to show my confidence and my skills?
Sure. So that's a good question, because like I said before, if you're coming in at an entry-level role, you're probably competing against 500 plus people for each job potentially. So you've really got to stand out. Like, it's super critical. And there's a few different things you can do. So one, of course, like I said, when you apply, follow up with people, message them directly. Okay. Another thing is to build a resume that really stands out. Like, your resume needs to be the simplest and easiest to parse, because no one's going to look at it for more than 5 or 6 seconds. Like, they're going to make an initial decision in 5 or 6 seconds. And if they can't figure out why you're good, like if there's just too much text on the page, if there's not enough white space, if it's not clear what your greatest accomplishments and your greatest skills are, they're just going to chuck it in the trash, because it takes too much mental energy to parse that information. So you want to throw away, just chuck all of the mediocre stuff, even chuck a lot of the good stuff, and just keep the great stuff in your resume so that you can control what they look at and what they see first. When they see your resume, you want to be sure that they're only going to see your best accomplishments, your best skills, your best attributes, so that they can make a quick decision to give you further consideration, give you a call, bring you in for an interview and stuff. So I mean, seriously, a lot of it's about resume design. It's not just about the work you've done. It's how you lay it out. It's how you speak. Like, you've got to use simple language on your resume, and you've got to be focused on the results. You've got to focus on the impact you've made. Now, even if you're a student and you haven't done any real world problems before, think about the hypothetical impact. Like, how could someone use this problem or your solution to drive value in a company? Like, if you do the Zillow project, you can talk about how a company like Zillow would be able to make better predictions and, be more successful, make more money. I'm not really sure how they make money, but right, like, show that your work could hypothetically be used by a company, and also point out really specific objective measurements. Like, I improved this model from 40% accuracy to 60%. All right. And simplify the design. You can use color. You can give it an interesting design that will stand out. Don't do the same resume design as everyone else, because they all look the same, honestly. If you flip through 100 resumes in a row, they're all going to look the same. Like, 90% of them use the same word template, just a whole bunch of horizontal black lines of text, and you just zone out flipping through them. So use a little bit of color. You can use 2-column approach. You can do different things, but just do something a little bit different, so you've got a nice clean resume that stands out and showcases your best work. And then, as I mentioned before, make sure you've got a good portfolio, but you only need like 1 or 2 really good projects. You don't need 10 different projects. In fact, it can hurt you if you have too many things on your GitHub repo. Like, you've got to have a GitHub repo. You've got to put that link on your resume, on your LinkedIn, so people can see it. But you only want like no more than 5 projects on your GitHub, because if you've got too many, people will look at the wrong ones. Like, you only want your best work up there, so that way when people go and look at your GitHub, you know that they're going to see your best project, your best 2 or 3 projects. So make sure that anything you forked, just make it private. No one wants to see a forked repo, because it's really difficult to figure out the work that you did versus the work that was already there. No one wants a forked repo. Class projects, unless it's a really significant project, just hide those too. Like, no one wants to see your homework on GitHub. And then if you did 10 different competitions, hide the 7 that are average and just keep the 3 that are really good. So it's really about controlling other people's perception of you, so that you present yourself in the best light possible, and focus all of your effort onto having a few outstanding things. Because a few outstanding things will make you stand out much, much more than like being pretty good at 50 different things.
Mm-hmm. And we have another great question here from Sekar. I want to add a little bit to this, like modify his question a bit, because it's more focused on.
Oh, sorry.
Can you?
Connection froze here.
Am I good?
Yeah.
Right. Yeah. So this is a question from Sekar. He said, "What is the best way to start with data science? And should I start with mastering the math behind it or focus more on machine learning.
Oh, well.
Yeah, so I think he was kind of concerned about like how important is machine learning and data science, or I guess like the 80-20 rule about data science. Like what's the core 20% skills that we should focus on?
Yeah, it's a good question. I mean, you've got to start with the math first. Like, you can't neglect the math and the theory, because you're just going to fall on your face later. Like, you can't learn all the cool stuff, and then, you know, when something goes wrong, you're not really going to be able to understand it. You can't really debug it. You can't tune your model effectively or apply the algorithm in a way that better solves the business problem. So you've got to start with the math. You've got to start with the fundamentals. You got to make sure you know calculus, and especially, you know, linear algebra is super important, and probability theory and statistics before you get started in machine learning, because you're just not really going to be able to understand machine learning very well without that mathematical background. Now, that doesn't mean that you have to go and get a math degree, okay? Like, you can do this in a few months to get a good enough intuitive understanding. Like, you don't have to do 2 years of real analysis and complex analysis and do every proof for linear algebra. Like, you don't have to prove everything, but you have to understand the mechanics of how it works so that you can apply it in the real world. So always start with the math first. Make sure that you understand that before you do anything else, before you learn the machine learning. And then once you've got the fundamentals down, just grab a data set, start by grabbing a real project and just start working on it, and let that be your guide. Grab a data set, and once you get stuck, you're like, well, I don't know how the hell to get this data out of a SQL database. So, okay, now I need to learn how to connect to a database. I need to learn SQL queries, right? So once you do that, you're like, okay, well, now the data's dirty. I need to figure out how to clean it. You're like, okay, well, now you need exploratory data analysis and data engineering and different things. So figure out the skills you need to do that. And then you're going to need to model, right? You're going to need to understand the business problem. You're going to need to build a model. So now you're going to need to go out and say, well, linear regression isn't very effective here, so I need to start learning some different techniques. I might need to learn tree-based algorithms or something else. So don't try to just learn in a bubble, in a vacuum. Like, grab a real data set, grab a real problem, do something cool and exciting that's engaging for you, and learn so that you can apply it right away. Because if you apply your knowledge, you will understand stuff better, you will retain it better, it will mean much more to you, and honestly, you'll just have more fun too. So, you know, learn by applying your knowledge. Like, get the fundamentals out of the way and then start applying your knowledge.
Yeah, I would like to add to that too, because when I was studying back in college, especially calculus, my tip is to always have like that big picture in mind. Where are you going to use this set of tools or skills, and how are you going to apply it to any sort of problem? Because if you don't have that in mind and you're just learning for the sake of like, oh, I got to learn, that's not enough. You have to actually like have some important usage for it, whether that be something for a company or something that you have like a problem you have with your computer, anything. Once you have that down, and as you apply it, it's going to retain in your head way longer. So that's just one of my tips.
Yeah. Learning without purpose is just a recipe for forgetting, man.
Yeah, exactly. Oh, okay. We have a really good question. It's a different one. So Bruno asked, can you show us the books behind you?
I mean, I got a whole bookshelf here, but I got a few on software engineering over here. So here's a few that I've either read recently or been reading. I haven't really gotten to the Scala too much, but the other ones are fun. Clean Architecture and Pragmatic Programmer. These are both really good. I really like both of these. So this one's like on software design. It's really awesome that a lot of data scientists really neglect understanding how to design software very well. In the middle, we've got some cool ones. Deep Work. So this is awesome. It basically talks about how to learn more quickly and how to focus, which is really by isolating yourself. So one thing I do is like, I turn my phone off and I put it in the other room. Like, you literally cannot even contact me during the day because I don't look at my email. I turn my phone off. It's in another room. I'm just impossible to contact because I want to be able to focus and actually be effective learning stuff and not get distracted all the time. There's a couple other good ones here. Scrum. So if you guys haven't read this is a really good book that you should understand agile development and Scrum. As a data scientist, it's really going to help you develop the right mindset for solving business problems efficiently, because really what Scrum is about is focusing on things that are important, like prioritizing all of your work, figure out what's absolutely fundamental to basically move the needle to be successful and move things forward, and focus on that first. So this is a really awesome book as well. Mindset, this is good if you haven't read that. I mean, I know you guys can't just read 20 books tomorrow, but The Power of Habit, I love this one too. This one's amazing. This
I
one's,
heard that was good.
it's about, helping you develop positive habits in your life and break old ones, and really understanding the mechanics of how it works, and how your brain kind of chunks patterns and moves them into your basal ganglia, and what you can do to essentially override habits. Strategy, this one's massive. I haven't really gotten into that too much. And then I've got a bunch of, I think I posted all of these on LinkedIn before. These are good though. Practical Stats for Data Science.
That's good.
I haven't read this book yet, but it might be a cool one for beginners. I think my camera's out of focus.
Neural networks, math.
Visual Intro for Beginners. So I haven't actually looked at this too much, but it might be cool for beginners. Python for Data Analysis. That's another really good one. This will teach you pandas really well. Like if you're just getting into it, this will teach you data engineering and basically how to deal with data and pandas and stuff in Python. Hands-on machine learning. This is one of my favorites. This is awesome.
Really good.
Yeah, this will teach you scikit and TensorFlow. Python 3 object-oriented programming. So this is another good one that'll teach you kind of a little bit more advanced object-oriented programming, which again, a lot of data scientists kind of sleep on the importance of software engineering, but it's really critical and able to build a system that's repeatable, that's modular, that's robust and easily tested and extensible and stuff. Like you've got to focus on the software. That's a good one that's Python specific. If you know nothing about data science, this is a really good place to start. Data Science for Business.
That's great.
Yeah, because they really kind of just give you a high level overview and talk about like, hey, it's about applying techniques to business problems, and it's not all about, having a PhD in computer science or stats or something. And then here's another cool one as well. This is kind of my other second favorite one for learning how to do machine learning in Python and learning scikit and stuff. This is a really cool guy, Sebastian Rashka. I've heard him talk a couple times before. He's a good speaker too.
Okay.
So that's a few of them. That's a few of the visible ones. So without spending the rest of the hour, I recommend all of them though. All of those are great.
All right. Okay, we have another question here. So from Abbas, I'm thinking about going to like a data science bootcamp or going back to school for a master's in data science. What do you recommend as a path one should take to get the necessary skills now?
I would avoid spending that much money. Honestly, I don't think that the university education is that valuable. I think that it's way overpriced and they under-deliver for what they promise you. That I wouldn't recommend going back to school to get another degree unless you absolutely need it. Now, everyone's situation is different, so don't take this as gospel. It's not like 100% of the time true. But personally, when I evaluate candidates, I give basically zero thought to their degree. If it's a PhD, a bachelor's degree, it doesn't matter. The school they went to, it doesn't matter. I only care that they can do the job. You can do the job or you can't do the job. Doesn't have very much to do with your degree. So I don't really recommend going back to school unless it's something you really enjoy and you don't mind spending a bunch of money going to school and a bunch of time studying. Like, that's fine. If that's what you want to do, that's awesome. Boot camps can be okay, but really research which one you do, okay? Because they're not all created equally. Some of them, I see people come out and I was like, man, whatever you paid too much because they didn't teach you, how to do things correctly. And I've seen people come out of other boot camps where they're pretty consistent with, their ability to land jobs. So if you want to do that, I mean, that's fine. But research it and just don't believe them just because they say it's good, right? Because a lot of this stuff you can learn on your own. Like I said, ultimately, if you can prove to companies that you can do the job of a data scientist, you can show them a couple projects that they know that if they hire you, you're going to be you're going to drive value, you're going to be effective on the team right away. like you'll get jobs, right? So it's not all about the degree. I don't think that they're typically a great way to learn. So definitely do your research, do as much self-learning as you can, develop some awesome projects, and see if you can just get some experience first. Like just get into a company, at least get something like data science adjacent, okay? You get a data analyst role, a software engineering role, a database administrator, working on the insights team, doing Excel stuff. Like just try to get some experience, get your foot in the door, and then just get in there and absolutely kick ass, right? Because if you join a company and you really help them make money, you will get rewarded, okay? It's a lot different than academia where you have to put in years and years and years and years to get rewarded. Like if you join a company, you start driving value, you really help people be successful there, you'll get rewarded. You'll get shifted onto the data science team. So you don't always have to have the degree if you can prove that you can do the job.
Yeah. And I also like to add to that too, especially if you're very new to college or if you have no experience, it's very crucial to have like any internship experience or just any experience in general, because it's a totally different like perspective, academia and just business. And one tip I have is, I made a post about this. It's like in college, you're evaluated based off of your grades, 70%, 80%, 90%. But then if you're out of college, you're just evaluated based off your skills and what you can provide to the company and like what you can offer. It's either you did it or you didn't. That's it. So that's why I emphasize a lot on just experience, get your foot in the door, just to see how data is utilized, like what you can do with it, how it's stored, and then always ask questions, because that's what companies want. They want people with curiosity and like different ways of thinking, so they can provide like different aspects of information to a company that they haven't thought about before. So that's just one of my tips.
Yeah, that's another great point, Randy, because the reality is like questions are the answer. If you don't ask questions, you never look for the answer. Like knowledge doesn't just pop into your head. First, you've got to seek it. Like you've got to guide yourself. I've got this question. I want to learn these new things. And that's when you learn more. That's, to your point, that's when you become more effective for a company, helping them solve problems in a different way.
Mm-hmm. Okay, we have another question. This is kind of like a supplement to our previous one. It's from Venkata. So are there any data science forums, groups, or discussions from your side which will help guide the upcoming data scientists? I would believe it would be a very good way to get in touch with them and any experts and enthusiasts.
Yeah, so first let me say this, like there's this pitfall that people fall into, especially when they use the internet. They just get overwhelmed with the amount of information out there. All right, there's so many different sources of information. There's so many different forums. There's so many different people to follow. There's so many different books to read. Like you've got to basically come up with some roadmap. You've got to find like one or two people that you think can help guide you and just listen to them. Just like keep one or two consistent sources of truth. Otherwise, you're going to end up getting pulled in 20 different directions, right? Because you have to think that it's not just about the tactics, it's about the strategy of how you align things together. So find like one or two people you trust and just rely on them and stay focused on what's important, which is improving your skills and improving like not only your technical skills, but your skills in the job search, because the job search itself is a skill. So don't get pulled in 20 different directions, taking advice from a bunch of aspiring data scientists, because like, no offense, guys, but aspiring data scientists can give pretty terrible advice about getting a job, especially if they've never gotten a job before, right? Like, don't listen to someone who hasn't done it before. It's not necessarily, like, sometimes it's good advice, but it's not necessarily reliable, especially if you've got, like, 20 different people that have never hired anyone evaluating your resume for you, and they've all got their own opinions, but it's not really based on experience. So stay focused, find a few people that you trust, and just try to like keep your head down, get advice from a couple people, and just keep moving yourself forward, and don't worry about like what the 20 different forums tell you to do. It's just not going to help you move your job search forward effectively.
Mm-hmm. Agree on that. We have another question from, let's see. Oh,
hey, I saw one guy ask, should we learn Java? No.
Okay.
Next.
Yeah. Yeah, if you do see a question that's interesting, just feel free to just blurt
I
it out.
thought it was quick and easy.
Yeah. Okay, so from Sammy, which tools after Python and machine learning algorithms is essential for data science?
Yes, I mean, I would say the secondary things. I mean, SQL would be the one thing that I would go to next because almost every company is still using SQL. Even all the ones that ask for Hadoop and big data technologies, pretty much everyone has got the company data sitting on a SQL database somewhere or some sort of relational database. So learn SQL so you can deal with data, so you can pull data, so you can do some data engineering and stuff. You don't have to go super advanced, but you want to be able to get your hands dirty and work on data and not rely separately on an engineer to do that for you. And at that point, you've got some different choices. Like it's kind of whatever you find interesting and whatever you want to do. Like if you want to be more on the analysis side, learn R because R is really great for doing quick exploration and visualization and different stuff like that, but not necessarily creating production level models that are going to be automated on a large scale. So if you want to do that exploratory work, then go with R. Right? If you want to be doing more data pipelines and more big data type work, you're going to learn Hadoop and Spark and different things like that. So start with Python, get the SQL down so you can wrangle the data and stuff, and then just say, hey, what's fun for you? What's cool? What are you passionate and excited about? And then you can learn that stuff. But again, don't try to boil the ocean. Don't try to learn everything at once. You don't need to learn like 50 different technologies to get a job as a data scientist.
I have a question for you to answer about similar question, but what's your thoughts about communication?
Well, it's
as a skill?
It's super important, man.
Say that. Okay.
It's
I was kind of missing.
I got a couple here that are good. Storytelling.
Yeah, that's a good one.
Speaking as a leader. I mean, there's a lot of different books on public speaking and stuff. And understanding how to communicate clearly to people, it's kind of like the fourth realm of data science, if you will. If one is like business domain, one is math, stats, machine learning, one is computer science and computing. The fourth one is communication and visualization. Yep. That if you can't communicate the value of your work and essentially sell it to people in the company and sell it to your clients, then no one's going to derive value from it. Like it doesn't matter if you have the winning lottery number if you don't buy the ticket, right? If you don't cash in the ticket, it's worthless. Like you've got to not only have the right information and a good analysis and a good project that produces actionable insights, you've got to convince someone to actually execute in the marketplace to drive value for the company. So it's totally critical to not neglect that. And not only is it important to be a data scientist to communicate well, but you're never going to get a job if you're a poor communicator. It's just too competitive to give someone a shot who can't communicate well. So if you want to get through the interview process, you're essentially just pitching yourself. Like that's what an interview is. You're pitching yourself and your ability to solve problems and drive value at a company. So a lot of that is communication. And to your point earlier, Randy, being able to put yourself in other people's shoes and have that empathy to feel like, what do they need from me, right? How can I show them this in a way that makes sense to them, that they find relatable and useful, and they see that I'm one of them and I can help them out. So super critical to be good at communication, to be good at visualization, to be empathetic. And I know that I'm talking too much, but being able to listen to other people as well.
Yes. That was good. Thank you. Thank you for answering that. Okay, we have another question here. So, all right, from Tarek. Have you noticed graduate degree holders in math and theoretical sciences have more difficulty in data science business settings driving revenue because of a lack of business sense and acumen?
Yes. I couldn't quite catch the question. Is it more difficult to apply theoretical mathematics in a business situation?
Oh yeah, so just to reword it, he has a degree in math and theoretical sciences, but I guess he's trying to say that he lacks some sense of business. So how can you cope with that, like ways to learn, just like business sense?
Yeah. Well, so there's a couple different things you can do, right? So you've got to start thinking about every problem, not just from a technical solution, but how you would apply that technical solution in the business place. Think about, put yourself in the customer's shoe or in the end consumer, right? Like, who is the very last person that's going to be affected by your work? How are they going to be effective? And how are they going to be affected? And always think backwards and say, okay, how can I build a solution that will help the end user be more successful? Additionally, I realize that that's kind of a tough answer that I'm giving you, that I'm just saying figure it out on your own. The other thing you can do is simply show that you are enthusiastic and interested in interviews, because it blows my mind how many people who come from academia, right? They might be in a PhD program, they might have finished a PhD or a researcher or something, and they show absolutely no interest in solving the business problem. Like, it's people that I know have the technical skills to do the job that I simply do not hire because I don't think that they can wrap their head around applying their technical abilities to the business problem. So if you just show that you're enthusiastic and you're excited and tell them like, hey, I don't have this background, but I really want to learn more about business. I really want a more applied role. I want to get in there and understand how things work and how we can help make, our customers successful, to make the business successful. People will be like, all right, that's cool. That's awesome. Like, we can teach you. It's not that hard. But you got to show that you're interested and enthusiastic about it. Because again, it's one thing that just blows my mind. People come into interviews and they don't seem excited to interview at my company. I'm like,
Yep.
Why are you here? You might as well just go back home. You don't seem excited about this. And I realize that people have different personalities, but whatever it is for you, like, you've got to be able to show people outwardly that you actually care about being there, that you think it's a cool company that has cool problems and you'd like to be part of it.
Yep.
You don't have to be super animated, but you've got to show them somehow that you're interested in. It's not just a job for you.
Yeah, I'd like to add to that too. So back to the interview stuff. Kyle just mentioned, yeah, I agree totally. And again, so when you're applying for that job, you got to show like the enthusiasm, the passion, or like why you're so excited to work for the company. Because that's what they really care for. They're asking themselves, do we trust that person to work with us? Do we trust them to handle our data? Do we trust them as a person? Do we like this person? So always keep that in mind. And first impressions matter a lot. So smile, be confident, and give a firm handshake and just have fun. That's
yeah, absolutely. Because I think most people will tell you, they're like, they can learn the skills on the job, but I can't teach them how to be excited to come work for us and excited to work in marketing or whatever the field is. So like that's always like the long-term play, getting the right people, even if they don't have all of the right skills today.
Yeah, definitely. Okay, we have another question here from Venkata. Can you please give me a brief overview on your data science course or just data science courses in general, the content, topics, or data sets that they work on?
Sure. So, I mean, my course is unique. I won't spend too much time selling you guys my course here, but my course is a bit unique in the sense that I really just focus on the job search, right? Like, if you went to school and you've learned some technical skills, but you can't figure out how to get a job, it's really focused on showing employers that you've got the ability to do the job of a data scientist, getting their attention, showing that, pitching yourself in interviews and showing them that you can be successful, making sure you set up your resume correctly in your GitHub. And I've got a bunch of code examples and like hours and hours and hours of walkthrough, of walking you through the code and why you should design it this way and how you should set up your GitHub and do your projects and different stuff like that. Even how to negotiate, how to get people to interview you, how to get through phone screens, how to do research to understand companies better. And I really just break it down in a step-by-step approach of everything that you need to do if you've got some of the technical skills so that you can actually land a good job as a data scientist, and you can be that one person out of 500 applicants that ends up with the job, right? So there's a lot of other courses out there as well that focus on teaching you the technical skills. And there's a lot of cool, really free stuff on Coursera and edX and these different places that will kind of walk you through some of the different technical things. So I think there's a ton of cool resources out there to become a data scientist without going back to school, without spending years and years and years studying and getting another degree, or quitting your job for a full-time boot camp and stuff. And obviously, I think my course is awesome, and a lot of people have seen success that weren't able to get interviews, that were immediately able to start getting interviews and doing different things to make them more successful in the job search.
Mm-hmm. Oh, I found another really interesting question, and it's pretty important. So normally in a lot of interviews, they ask the business use case questions at a very high level. So Deba Brata asked, in a lot of interviews with case studies that doesn't have a lot of data, especially at a high level business problem, what kind of approach should we take when answering this?
Sorry, just lost you there for a minute, Randy.
Sorry. So the question was, in a lot of interviews, they give you a case study, which doesn't have a lot of data. So at a high level business problem, what kind of approach can we take to answer it?
Yeah. So again, stay super focused on how do you solve the end problem. First, really clearly identify what's the end problem you're trying to solve that's going to drive more revenue for the company. What are those KPIs? And then work backwards and figure out what methodologies you can use to actually drive those KPIs and make change. Now, if you don't have enough data to actually do it, that's fine. Just use the next best approach. Just keep working your way backwards to the next best approach until you can do the best thing you can. And then when you talk to them, tell them, hey, if I had more data, if we had X, Y, and Z, if I had more time to work on this, these are the improvements that I would make, right? This is what I would change. This is what I would do differently. This is how we would do it better. Here's the possible challenges, and here's how we'll overcome them. Because you don't want to fall into this pitfall of feeling like, well, I didn't have enough data, so I did this non-optimal approach. And then you go in there and they ask, well, why didn't you do this other thing? Isn't this wrong, or couldn't this be done better? You don't want to get put on your back foot like that. You want to control the conversation and basically tell them up front, here's the assumptions I made, here's the shortcomings, the challenges, and here's how we would overcome them if you hire me, right? So always think of it in that light of what's the best thing I can do right now to solve the business problem. And if I had additional resources, how could I make it even better? If I had more time, how could I make it even better? And brainstorm with them and get some feedback and make sure that you're always going down the right road. Don't just start talking for a long time like I am right now without getting any feedback. Mm-hmm. Make sure that you're getting feedback and they're saying, yeah, that is the problem we're trying to solve. Yes, that is a challenge. Or they might give you new information that you didn't even know before. So make sure you engage them. You're getting feedback from them. You're talking, you're listening, and then just hit them. Here's the best approach, and here's how we could make it even better with more time and more resources.
Yeah, that was all good. All on point. We're going to wrap up.
So, stuff like that is what I teach in my class, how to do that, right?
I'm going to give you 2 more questions, and then we'll wrap it up.
Sounds good.
So, second to last question is going to be about, from Roshan. Do you recommend any online MOOCs to get started with data science? If so, can you mention some? Kind of generic.
Yeah, there's a lot that are good. Obviously, Andrew Ng's machine learning course is good. There's a few good computer science 101 type courses. I think Harvard has one, Georgia Tech has one, MIT has one. There's a lot of different resources out there that are good. Just pick one and stick with it. Make sure that you finish it to completion and don't just do it for a week or two and then quit and then start a new one and then do it for a week or two and then quit and start a new one, because you're just not going to get very far. So it's less important which specific one you choose, as much as are you consistent? Do you follow through and actually complete it and get the maximum value out of doing it? Oh, and Randy, I saw one other cool question that popped up here.
Yeah, go ahead, go for it.
Yeah, it was about police predicting crime. So here's a cool question that starts to bring ethics and a kind of a more complex business problem.
Yeah.
And in that, I feel like this comes up as a lot of case studies. If, how would you help a municipality reduce crime? And of course, it's very easy to build a model It's going to take information about the people, about demographics, about the city, time of day, weather, etc., and predict where crime is going to be. Now, the obvious solution that everyone says is, well, if there's going to be crime, we're going to send more cops there, and the cops will make it safe, and it'll be great, and there'll be less crime. And that's wrong. That's not what happens. When you send police somewhere, they arrest people. They find crime. It doesn't matter if it's there. Police go there. They find crime. And now you ended up with, targeting some specific demographic. You're in this profiling issue where you can't just send the police to places because the data might not be actionable because of ethics issues. So what you have to do is you have to think about the problem differently. You say, instead of trying to directly attack crime, what would we do to slow this down, right? What are the things that are inversely correlated with crime? So you start saying, okay, can we start putting more light posts up? Can we put more light in the neighborhood, right? Because streets with no street lights end up having more crime, right? What are the different things we can do to reduce crime? Or there was one during the Iraq War that was super cool, or it might have been in Afghanistan, but wherever it was essentially that there were riots being caused in city centers. People would gather up in the city center, and over time, a mob would form, and it would start to get violent in the afternoon. And this, I think it was an army general or something. His solution was not to try to police it harder or to fight people and crack down. His solution was take away all the food vendors. There were essentially little food kiosks, things that rolled into the city center, and you just take them away from the center of the city. And then in the afternoon, people start getting hungry and they look around for the food and there's nowhere to eat. And they just end up leaving and dispersing. And the crowd never really hits that critical tipping point to become violent. So you realize that there's other ways to solve problems than approaching them directly. And you can really leverage machine learning to detect what those interesting relationships are. So it's a really cool problem to attack. How do you reduce crime using machine learning?
Wow, that was really interesting. I was just jotting notes down right now. Okay, last question from Akshat. So what are your expectations from a candidate when giving them a data science project to work on?
Yeah, so I'm usually pretty clear on what I expect in the directions. I will give you some measure of efficacy that you should be able to hit. All right, so I'm usually going to say your error should be less than this. So that's kind of a minimum baseline. If you want to be considered, you've got to be able to kind of do those basics. And then the other thing I look for is what makes you unique? What makes you stand out? Do you do amazing, super thorough EDA and visualizations? Or did you do an amazing job tuning this model or doing different stuff? Or did you automate this system really well? Did you write really clean object-oriented code? Did you do these different things that make you stand out from other people? Because just doing it and getting it done and having a pretty good result is not enough, because you're going to be in the 80 or 90% of candidates that just get it done and do a pretty good job. And guess what? No one's going to stand out. There's really no reason to interview those people because they all kind of have similar results with a similar EDA, similar code that runs from start to finish with no real organization, no functions, no objects and methods and stuff. So one, you've got to do a good job. That's a given. Two, you've got to do something that stands out. And if you put in twice as much work as other people, it can be worth it. It can really pay off. People will notice that you're a hard worker. That doesn't mean you have to go work 60 or 70 or 80 hours per week at the job. But if you're willing to put the effort in to get the job, people will appreciate that because they'll understand that you care about the job, you're excited about it, you want to be part of it. You're going to do whatever it takes to make them successful. And ultimately, that's what you've got to do in business. You're never really going to be successful in life if you treat your career like a 9-to-5 job where you clock in, you work for 8 hours and you punch the clock and go home. You've got to be a little bit more dedicated. You've got to really care about the end result and be willing to do whatever it takes to make the company successful. So if you can show off that mindset a little bit in these projects, then that's awesome. And one thing you can do is make your code reusable. like don't start these take-home projects from scratch each time. Write your code in a way that's generic and modular so you can just reuse it next time.
Yep.
Right? Don't spend 20 hours on every single one of these. Spend 20 hours on the first one and then leverage the work you did to basically automate and pipeline your second project, your third project, your fourth project, like automate your whole EDA process. Just load in a different file. Mm-hmm. All right. So make sure that you stand out, that you do something differently, whether it's effort, whether it's a specific skill, you know, but you got to really stand out from the pack there.
Yeah, I also like to add to that. So whenever the case they give you like a business use case problem to solve, I agree with Kyle again, where it's really important to learn how to document your code, write clean code, and write some sort of pipeline for yourself that's reusable. Because when you're given the task, you shouldn't spend majority of your time thinking on how to write the code. You should spend majority of your time thinking about how we can like provide insights and question it. So that will save you a lot of time. And I think a good way is just to go to Kaggle, look at the notebooks and kernels that are top rated, and you can get a lot of inspiration on their code. So that's just one of my tips. So before I end this with Kyle's last message, I would like to share with you guys just a poll. So your feedback means a lot to us. So thanks again for coming. It will just take you 1 minute to complete. So I'll send it out right now.
Oh, hey, and Randy, real quick, I set up a really cool offer for everyone on this webinar.
All right.
Like I said, my course, I teach you how to be successful in the job search. You know, I take you from aspiring data scientist to actually landing a job and being able to stand out and get through all those interviews and be the one person that's successful out of 500. So I put together a cool offer for you guys. I'll just share this in the chat here. I just put the link there. So I just gave people a discount, and there's also a free 30-minute consulting session with me if you guys want to sign up. Obviously no pressure, but if you're interested, just thought I'd hook you guys up with a deal.
Yeah, sweet. Thanks so much, Kyle.
Oh, thank you, Randy. I had a blast. We'll have to
yeah, same here. Everyone had a blast.
Awesome.
And again, too, before we leave, I just want to thank everybody for coming. And again, networking is crucial. So if you guys have any questions, ask me, Kyle, or anybody from this chat on LinkedIn. So I really emphasize just networking, build that relationship, just build a network of like your data community. So we're all help, any questions. All right, see you later, guys. Have a good one.
All right, awesome. Thanks.
Bye, Kyle.
Hey, can you pin that link there for a second? People keep asking, it keeps disappearing. A lot of people are
I'll send it.
A lot of people are
hold on.
thanking us for the webinar and saying they enjoyed it.
Can you see it? I sent out your link, right?
There we go.
Okay, so I sent out a link to Kyle's LinkedIn. I sent out a link to his offer, if you can get it. And then I sent out a link to my LinkedIn profile as well.
All right. Awesome, guys. Thanks again, Randy. Thanks, everyone, for showing up. I really appreciate you guys taking your time. A lot of people woke up early. A lot of people, you know, are here instead of doing other things on a Saturday night, which is awesome because, like, one last tip, you want to get ahead in life, man, you can work when other people are partying. Like,
true that.
That's real talk, man. Like, if you work on improving yourself while other people are out there kind of doing destructive things, like, you're going to get so much further ahead in life, and it's really going to pay off later, and it's really going to be a lot more satisfying. So congratulations to everyone who's on here. Like, you guys are awesome.
Yep. Thanks for spending your weekend with us. And we do these webinars twice a month, these data webinars. So our next one's going to be in 2 weeks. Not too sure who the speaker is, but it should be a surprise. All right. Thanks again, everybody. Have a good one. Have a good weekend.